Okay, this is like my favorite factoring, which is factoring the difference of two perfect squares. Okay, what is a perfect square? Whoops. Okay, what is a perfect square, you guys? Let's remember that a perfect square is when you can say, for example, like the square root of 25. 25 is a perfect square because what times what gives you 25? 5. And you got a whole number for your answer. Okay? So that's how you know that 25 is a perfect square because this was not a decimal. Okay? So let's keep that in mind. So let's look at these words. Difference. Okay? Difference of two perfect squares. So here we have z squared minus 9. Okay? What is the factored form of this binomial? Z squared minus 9. Well, we have to talk about, we just talked about what a perfect square is, okay? But we do need to talk about what a perfect square is for a variable. Perfect squares for variables always have even exponents. So let me show you this. So x squared, x to the 4th, x to the 6th, x to the 8th, okay? We can see 2, 4, 6, 8. Those are all even numbers. Variables with even exponents are perfect squares because, once again, what was the requirement with the square root of 25? What times what gives you 25? That would be 5. That's a whole number, okay? So we know if I were to write it out this way, 5 times 5. 5 times 5 gives me 25. Well, what times what gives me x squared? Well, that's x times x because we know that 1 plus 1 is 2. What times what gives me x to the 4th? Well, x squared times x squared because 2 plus 2 is 4. Okay? So, what times what gives me x to the 6th power? X to the 3rd times x to the 3rd because 3 plus 3 is 6. Okay? So, when we're talking about variables, the variables with the even exponents are perfect squares. Okay? Very important. So, if you have x to the 7th power, that is not a perfect square. So you would not be able to factor it using what we're going to do today right now, okay? It has to be an even exponent. So as you can see, we have z to the 2nd power. So we're in luck because that's an even exponent, okay? And we have 9, and 9 is a perfect square. Why? Because what times what gives us 9? 3, okay? So if we want to factor that, okay, if we want to factor that, we have to say what times what gave us this binomial here. So let's put in 1, 2, 3, 4. So what times what gave me z squared? Well, that's going to be z and z, right? Because z times z is z squared. Now all you have to say is what times what gives me a negative 9? Well, that's going to be a positive 3 and a negative 3 because a positive times a negative gives you a negative, and 3 times 3 is 9, and you're done. It is that easy. So when we're talking about what you're going to look for, you guys, we're looking for two perfect squares, and we're looking for subtraction in between because it says factoring the difference. Difference means subtraction of two perfect squares. Well, look here. Here's subtraction. This is the difference, and these two terms are perfect squares. So that fits the bill. So you can just break it down into your two binomials and say what times what gives me z squared and what times what gives me 9. Okay, so let's do 2 more examples. Okay, here we go. What is the factored form of each expression? Okay, so let's set ourselves up for success and write our 2 binomials. And we can see this is pretty easy. V squared, that's a perfect square. That's subtraction, so that's the difference. And 100 is a perfect square. So all we have to do is V and V, because V times V gives us V squared. And 10 times 10 gives us 100. But it has to be a positive and a negative, because a positive times a negative gives you a negative, okay? And then another one here, S times S gives you the first term, S squared. And 4 times 4 gives you 16. But one needs to be a positive and one needs to be a negative. What if it was, let's just say, another perfect square, 64 x to the 8th minus 144, okay? Give that a try, and we're going to find what is the factored form of this expression. Well, luckily for us, okay, they both, foot the bill, they both qualify, because 64 is a perfect square. X to the 8th power, that's a perfect square because it is an even exponent. Difference means subtraction. And 144 is a perfect square because 12 times 12 is 144. So what do we put? We're going to put 1, 2, 3, 4. So what times what gives us that first term? That's going to be 8x to the 4th and 8x to the 4th, because 8 times 8 is 64. And x to the 4th times x to the 4th is x to the 8th, because 4 plus 4 is 8, right? And then we have 12 and 12. And a positive and a negative, because a positive times a negative gives you a negative, and 12 times 12 is 144. That's factoring the difference of 2 perfect squares.